Muted. Okay. My preview in OBS looks totally shitty. Do you get pixel garbage on your end, or do you see a proper video of me? Dun, 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 dun. Technical difficulties. Okay. Pixel notch. Yeah, ugly as shit. I'll just reconnect my GoPro. Give me a second. Bye bye, GoPro. Hello, GoPro. Better now? I should be audible. Hey, come on. What the heck? It's the GoPro acting up. Yeah, at some point I need to get dedicated hardware for this. Okay, it's just laggy sound. We can live with it. It's barely lip sync anyway. So, let's get started. Welcome to the Thursday tuning talk. It's Friday, I know, but come on, the GoPro is acting up. Let's see if I can change it to 30 midstream. No, I can't. Bitrate, encoder, faster. No, it doesn't look better now. Ah. Oh, come on. Yep, that would be a tough one. It's popping in and out. I don't know what's up. Mm. I'll put the bitrate down a bit. But I think it's the GoPro going crazy. Do I have another GoPro over here? Wait, I have the GoPro. Okay. Bad camera. You're gonna be replaced by the other bad camera. Give me a second. And let's see if OBS is more happy. I'm out. Dun, 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 dun. Yeah, Chow, I'm working on it. Hmm, let me mount this anyway. It's no, it's getting hot. I had it on for like 5 minutes before the stream, and oh, this looks disgusting. Uh, so talking head, GoPro. Oh, damn it. Now it's here again, and it will be back out in a couple of seconds. I don't know what's up. Okay, I threatened my computer to update the NVIDIA driver, and it started working. Okay, we'll try to go on like this. I hope it doesn't cut. No, it's cutting out again. Ah, that's not fun. Know what we're doing? I'll put the screen here, and you got this pixel match on the bottom right. I will just go on with the stream, and you can make fun of me all the time. Uh, so welcome again to the random pixelated slideshow Thursday tuning talk. I'll do the basics and explain how you get started to look into your logs. So I'll cover Blackbox Explorer first, and then I'll head over to PID-toolbox. So to install Blackbox Explorer, it's always a nice idea to just fucking Google it. Blackbox Explorer. How exciting. First hit, nice, is the release page on GitHub. So let's open up. Here you got all releases. If you want a nightly build, on top here is the community Betaflight, which hosts Betaflight firmware, of course, the configurator, and Blackbox Explorer. But if you check out the repositories, you'll find the nightlies as well. The nightly builds are the current last night's builds from the master branches of all the software. So if you want to have new hardware that's not supported, you can use the Betaflight Nightly. So you got a 4.5 version, 3 days old. You have to be cautious. It's beta software, of course, but I'm running 4.5 since over half a year, and didn't have a single issue. So it's worth trying. There's always some new things coming, and you can try it out. So I'll take the configurator nightly. Find the releases. It's over here. It's releases. Wait. Yeah. Okay. Ah, of course, my head is in the way. Wait, I'll just put this window to the left and then point my mouse at the releases. Meek, 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 meek. And there you have all the compiled versions for different operating system. For me, it's Windows 65, 64. There's a macOS, a Linux, and an Android version as well. So I'll download this. It doesn't take too long. Once you downloaded it, you just run the installer. That's it. Betaflight isn't too picky from where it runs, so the Blackbox Explorer is not picky. Oh, Windows saved me from good hardware, good software, so we'll run it anyway. While the installer is running, I'll explain how to set up your traces to choose what you want to see from the black box, because there's a lot of data in it and you don't need to see everything. Oh, yes, I want to run the installer. And UAV Tech Max Betts is really a nice guy. You should look into his stuff. Why Korean? I don't want Korean. I want it in English. Okay, here we go. So UAV Tech, a little Google foo for Tech trace templates. Let's see if it. Yep. Google points me to the right directory again. Did I just download configurator instead of... I'm such a loony. Okay. I just downloaded Betaflight configurator instead of Blackbox Explorer, but I'll update to the latest version, to the latest nightly build. And so if you didn't get it right the first time, I'll do it again. I'll go to the GitHub main page from Betaflight and Blackbox configurator nightly, Blackbox log viewer nightlies. Here it is. Let's download the latest build for Win64. That sets me back another 100 megabytes. Open. Where is Blackbox Explorer? No, that's not his traces. Let's go through his main page and see. Utilities, performance. What's the performance edition? Let's see what UAV Tech's performance edition is. Oh, F3 boards. What the fuck? Okay. He has a couple of slimmed down Betaflight builds. This was obviously before they did custom builds for every download where you choose what features you have, because starting with Betaflight 4 old boards with less than 512K onboard memory ran into memory problems. But hey, Mark, where are your trace templates? And no search function. Come on. Don't make it so hard for me. Okay, we'll go on his YouTube. And he might have, no, it's not his YouTube. Okay. UAV tag trace setups. Why is this a PDF? Okay. Because he had templates downloadable. I didn't use them, but they made sense in a way. Configurator is installing. Blackbox Explorer is downloading. I'll be with you in a second with more information worth it. Come on. It's like 1 megabyte to go. But my face is... Oh, I see. Now the GoPro is working. That's at least the thing. Yeah, I didn't realize I have a couple of those Flywoo GPSs, and I built one into a rig. And I had the AIO is it's a Flywoo AIO, and it still had 4.4 on it. It travels with the rig, and I don't have a USB port available without tearing apart half of the rig, because this is a test board. Okay, configurator is done, and oh, come on, Blackbox Explorer. Okay, you download it, you just double click the installer and run the Explorer. It should give you a nice little link on the desktop if it's not totally cluttered and you can't find anything. So I'll Maelstrom sold Beavers with templates. Yeah, where are they? I sorry, I can't find them. But I'll just head on and show you how to work from a blank template. While I'm at it, you wanna see my Discord? Why? No, that's OBS. I wanted to move Discord, not OBS. So that's better. OBS obviously don't like it. I had some guy on my Discord ask me, seriously, God, nothing is working today. Ask me to look into a log of his. Here it is, 7th test flight. It's AOS 3.5. Okay, all my downloads spaz out for no reason. I'll just kill it. Yep. Okay, let's download this again. Oh, come on. Yeah, Blackbox Explorer usually links the file type, the BBL file type, directly to open it within Blackbox Explorer. but my computer is messing me up today. Yeah, Maelstrom, you can compare it to your own logs. Blackbox Explorer will always open a new instance. If you open another file, it will open a second instance, so you can have more Blackbox files open side by side. So here it is. Those are the traces that I usually use. I think on a fresh install. No, I'll just blank it out for now. Remove, save. Okay. I don't know what's the basic setup, but if you got nothing, you have on the right hand side a place that shows which traces are currently displayed, and the graph setup where you can choose what to display. So you have gyro pit and roll, pits on roll will give you PID and feed forward for the chosen axis. So I use gyro, gyro and pit for roll and for pitch. I'll have the motors. Which in my case, most cases, is you can add another field here. Motor 4, no 3, and one more, motor 4. Too fast here. And usually, I think still till Betaflight 4.4, the raw gyro data, if you selected it in your logging settings in the Betaflight configurator, are in debug. So it's a debug mode where you have gyro scaled. Where's gyro scaled? I'm blind. Oh, he didn't log gyro, so we'll use it for now. Is gyro scaled active? Let's try. So this work you don't have to do often. You just save it here as a workspace. Oh, come on. Move. My funky traces. Unnamed? No, I want to name it. Just my funky traces. Okay. And if you change something, you can use this save icon to save it. So this is what most people do. I usually add RC command on one axis at least. So on RC command you can judge what control system was used. So here you got the traces. Let's move somewhere where something is happening, actually. Down at the bottom you have a preview bar. On default it shows the throttle value, but you can find places where you are running full throttle to judge what happens. Usually one motor saturates and the others are a bit slower. Or you can choose a throttle cut where you're on really low throttle to see if any vibration is lower than the RPM filters are allowed to go. But over here, you have only on hover, you have a select box where you can change this to maximum stick input. This shows the stick that's the direction, the highest input. So if you're on roll, pitch, and jaw, so you find it's easy to find snap moves because those are the response that you will tune for. There's a lot of noise making it here into D term. We'll have a look at this in a second. But it's a pretty good balanced tune, so it's not overshooting, it's following pretty tight. If you want to judge one axis, you can just click on the head of the group and it will give you just this group. So you have a better view on it. So there's D-term just going crazy when it drops the throttle. Might be the RPM filter is not going low enough, but we'll see in a second. Brandon, what do you mean with has correct motor poles working? It can't detect how many poles your motor have. Or is the input field, did the input field not work on an earlier version? So the traces tell you gyro raw tells you what the sensors are putting forward to the flight controller, what the gyro sensor is seeing. The gyro data here is the filtered gyro data. Set point in, let's blow up. Zoom in, use just one trace. On this graph, you can see it a little better. Set point is what you tell the quad to do. RC command is the raw input it gets from the receiver, but there are no rates applied. So this is just -1000 to +1000. Should be. Yeah. Oh no, it's 1000 to 2000. Sorry, it's duty cycle. And set point is after the rates are applied. So if you move the stick down, there's not a lot happening because you have low center rates, maybe expo. And once it reaches the top, it gets closer together. If you want to see what rates are happening, just go into such a snap move and you read the rare value here. So you see set point is 590 degrees per second. Won't get bigger. Yeah, that's what it choose to fly. And those are the terms that are calculated within the PID controller. It's the P term, which just tries to close the error between those two lines. The D term, which tries to keep the blue line always horizontal. And the I term, which tries to close the rest of the error slowly if it's persistent error. If your battery is shifted back, then your tail motors always have to work a little bit harder, and it's not enough for P term to really correct it. So I term will sum it up and keep it where it is. Feed forward will react on your stick input independently of what your gyro says. It will just react to stick. So it's especially at the beginning of a fast move, you want the quad follow your stick and not the error that is happening, not waiting for the error to happen. And the PID sum is just the sum of PID and feed forward. So this is what goes into the mixer and finally into the motor outputs. Okay, let's talk about filters. We'll just take a frequency spectrum first. So this is the gyro signal translated in the frequency domain. It's a bit sloppy implemented. We will do better within the next couple of months. We'll fix a couple of things and might come up with a better solution. On the x-axis, you got the frequency. The highest frequency is always half of your locking rate, because with your lock 2000 values per second, you cannot capture frequencies above 1000 hertz. That's a Nyquist's law. You can't find the spectrum would go on here, but everything above this line is just garbage. Joe, you're welcome. You can zoom in to get a more detailed picture of the lower frequencies, and you can zoom out, of course. No, you can't zoom out further than your log would make sense. Please, if you watch a log, leave the gains where they are. Those are sensitive gains. If you see on the left hand side a big red bar like this is actual movement of the quad. It can move 20 hertz, maybe, yeah, up to 60, 70 hertz. That's just movement of your quad. The more you work it, the harder you fly into prop wash, the wider spread this peak will be. But if you have a solid peak red peak here, don't turn up your gains. You gain nothing by it. It's just you lose resolution down there and you think you have so much noise. No, you don't. Just leave your gains where they are. Yeah, this is, if you work here, if you press the shift key on a spectrum, you get a green bar that tells you precise frequencies. If you want to manually notch out a resonance of your frame, if you suspect this is a resonance, you can just put the bar here and say, okay, I have 400 hertz. It's reaching like from 380 to 420. So I will set a notch with 400 center and 370, maybe 375 cutoff. Over here, you can choose the plot you want to see. Now, the more interesting or easier to read plot is frequency versus throttle. This will take a while. Sometimes you need to click on the value. Yeah, when you have the spectrum a plot open, or over here open, a small one, once you click on a value, it will give you the plot for this value. So I can look at the roll axis, at the pitch axis, but I can also look at the filtered gyro signal. This is what, oh, the fuck, okay. Oh no, okay, it's okay, it just took a while. And more interesting, the gyro will tell you what's left after the gyro filters after the low passes, the RPM filter and the dynamic notches, if you use them, or static notches, run over the signal, over the bare signal or gyro raw. This is the noise you got in your gyro. Here it is. We have a really nice first harmonic and a third harmonic, and a teeny weeny resonance is at about 220 hertz. After the gyro filters, this is what. Wait for it. It's coming. Here it is. Okay, this is what got left. If you got horizontal bars here, don't mind too much about it. Those happen. This plot, this frequency over throttle plot, does the Fourier transform, which basically gives you the frequency, the volume of the amplitude of the frequencies from the raw signal, and it does it for certain throttle values. And I bet you this is just his hover point. At 24% is where he's hovering. If he's flying forward, this is his cruising throttle. This is how far his thumps reach when he punches, or when he's flying hard and faster. And he's not using this throttle range a lot. So this weak horizontal bars are nothing to be concerned of. They're on every log, depending on how much they're. Yeah, Joe, put it in Discord. I'll have a look at it later. This is still the AOS 3.5. So you see, we have just one first harmonic, and this is the third harmonic. Because on props on rigs with triplates, you never ever see a second harmonic. I hope this will get. Yeah, I think it should. It is on the 4.5 timeline, so you can phase out the second harmonic and just use the first harmonic and like 30% of the filter for the third harmonic. So you gain a lot of processing time and filter delay. By default, you will see the currently set low pass filters over here, but it doesn't show you all the filter setup. Top here, the info bar, the little eye, shows you the setup of the rig or the current used parameter. Betaflight can't put the full dump in here, but it's like 90% of the relevant or 99% of the relevant parameters are in here. So let's see, the gyro low passes are turned off, which is totally fine. I don't do this, but it's totally fine on a rig as clean as this. RPM filters, he took his time, set the minimum a bit higher, which is totally legit. 100 hertz is good for 50 for a 5-inch rig. On 3.5, I usually set the minimum 130. But you can easily just see how low does the motor noise reach down. And it's really, after this little frame resonance, you don't see a lot. It's maybe coming down till here. That's 177 hertz. So if the RPM filters start at 125, they are in full effect at 175. So he could even go lower, because this resonance, the notch filter for this resonance, the dynamic notch will eat the part from here to here. So he could easily go to start the RPM filters at 150, yeah. Even 160 would be fine. The smaller the rig gets, the higher you can go with the RPM filters. On a 7-inch, you already need to go down to like 80 hertz and lower the range. On some rigs, it's better to lower the fading range, but you have to go to the CLI. So let's say we have frame resonance at 220, a small one at 330. I'm not sure. The resolution is not good enough, but maybe one at 400. This should be handled by low pass filters over here, but the RPM notches will take care of this. When you see a slope in the other direction, this is aliasing. So this is aliasing from the third harmonic. The third harmonic is like 3 times the frequency. So at full throttle, we are at 560 hertz. So this times 3 would be, yeah, no calculator needed, 1500, 1600. But you only sample, we only sample for the black box at 2000 hertz, so it will reflect the 1000 hertz. You can see that slope is going up here, and at the Nyquist frequency we get the mirror of it coming back here. So if you see a line going in the wrong direction, it's just a sampling problem. Just imagine this line going out of the screen on the right hand side. Oh, did you see my mouse pointer? Yeah, this is the reflection of this. So judging the filters, let's see where he put his dynamic notches. 2 notches from 150 to 500, no, to 700. He should go lower with the maximum frequency, because the dynamic notch works with, I think, 128 buckets. So you have this range from 150 to 700 hertz, and you have 128 buckets. Make it easy, call it 100 buckets. So you cover about 600 hertz with 100 buckets. You have 6 hertz per bucket, and it's got spread out on the higher region more than on the lower region. So if you see you don't have any resonance above a certain value, just put the max frequency for the notch 20-30 hertz over it. Same on the low side. You don't want to go too low, but at least 10 hertz under the actual peak. Otherwise, it can happen that the lowest notch misses the peak if you're not clearly below the resonance frequency that you get. Well, so let's see his filter setup again. He's using sliders for D-term from 80 to 160 hertz, and we still have this noise in D-term. I don't know why this is not filtered. Let's make it even bigger, because this is a lot of noise going on. Let's see what frequency. With M, pressing the M key, you can mark a position in the log. And then if you scroll through the log, it will give you the time distance between the mark and the actual position and the frequency that it relates to. And there D term is resonating, because P is not. No, P term is resonating too. So gyro, we have 300 hertz over here, and it's happening when he cuts the throttle. What's happening when you cut throttle with dynamic filters, the cutoff of the filters goes down with the throttle. It's meant, the idea behind it is the more throttle you put in, the higher the frequency will be. So we don't need to filter on the lower end that much if we are higher in the throttle. So that's why Betaflight behaves much better in prop wash when you're on the throttle than when you're off the throttle. So flying into prop wash, when you do a dive and flatten out, when you flatten out with zero throttle, you got the worst prop wash. And if you do the same dive, flatten out and hit the throttle, you will see it stabilizing instantly because the frequency of the low pass cutoffs will immediately shift up. So let's see where else we got this. It really hits when he drops the throttle. So let's zoom in again and see what frequency we got here. Mark over here. Yeah, it's all in the 300 hertz range. Did I just close this instead of, hey, how to get my graph back? I want my graph back. So we got a frame resonance, obviously somewhere at 300. Yeah, it's this one. But it is, let's see if it's any different on, always check both axes, because oh yeah, you see the resonance much better over here. So we got this one at 280 and this somewhere between 370 and 400, but it takes a lot of motor noise with it. On low throttle, it's exactly this what we're looking at. It's 360, 390, and the second one is around 280, let's say. Let's see on roll again. It's slow. Why is my machine so slow? Yeah, I don't think it's this at 250, but I think it's this noise over here. But I didn't see it in the gyro plot. No. Let's put the crosshair. I don't see this in the gyro, which is weird. Okay, I told you not to touch the gains to judge your rig, but I will now. But it doesn't change shit. So it's in gyro where it actually shouldn't be. And let's see how the D term behaves there, because it should be visible in D term. Yeah, we got the resonance over here, but that's not it. And the frame resonance, which isn't that bad, it's not that either. Somewhere around 300 to 360 in here, but there's very little noise visible. And I got a system frequency of slightly below 60 hertz. That could be faster, but I wouldn't put any lower. So what I would try to solve, how I would try to solve this is put in a third notch, a third dynamic notch, shift to give it a bit of a tighter region to work on. Like start at 200 and only go up to 550. Let's see. I usually use low pass filters to get rid of the rest of aliased noise. It's my bad experience with 4.3, I think, where they haven't fixed the driver for the ECM gyros, for the new ECM gyros, which are not new anymore. Like half of the manufacturers put them on their board, like even more. Um, so I usually leave these on and just pull the gyro slider, depending on the rig. If I have no electrical noise visible, I just pull it to 2, and I at least have a little bit of low pass filtering with like a quarter of a microsecond of a delay. It's no millis. Is it millisecond? Yeah, it's milliseconds. Quarter of a millisecond of delay, and that's fine. It's better than risk getting electrical noise. If you lose your capacitor on your flight, your rig will spaz out without the gyro low pass. Yeah, lower notches. The RPM, a Q of 500, even 600 would be fine with this rig. It's clean. You could go a bit higher with the minimum frequency to gain the last bit. Oh, okay. He's using no dynamic D, which makes it more predictable in the tune. But the reaction to throttle that people often blame the reaction of D term towards the throttle on dynamic G. It's not. It's the dynamic filters. It's the low part the cutoff, the changing cutoff frequency with the throttle, which is making D term react to your throttle. Where you see when you get higher in the throttle, D term gets smoother because it's not delayed that much, but it's not dynamic D. Dynamic D, you barely see artifacts if you don't use a lot of it. So how I balance my rigs is I use 0.3 to 0.5 of D max and less D gain. So you will have less D induced vibration on low throttle, and you will still have enough D when you work the quad a little bit harder. I'll just check the Discord what the guy said about his rig. My P on pitch could be a bit smaller, and maybe dynamic notch could be a bit off. Yeah, dynamic notch, definitely 3 notches on this rig, and the frequency band we've spoken about. P on pitch could be a bit smaller. Let's see what P on pitch does on this rig. No. Feed forward could be a bit smaller, but it's hitting set point really. Let's put zoom back. It's hitting set point really nice. So I wouldn't. Let's remove the marker. So you have so little delay here, and you don't on the acceleration into the snap flip. You don't run into motor saturation, and on the deceleration you run into motor acceleration, and that's mostly due to feed forward. So here you start when you're still working on, yeah, did you say pitch or roll? Sorry. P-term on pitch. No, I would use a little bit less feed forward to keep P-term on the right side. No, you're fine here. You have iTerm winding up a little, but nothing to be concerned of. No, no. If anything, even no, no, you're really, that's a nice balanced tune. Brian is here. Hi Brian, how are you doing? We just finished almost finished talking about Blackbox Explorer. So we walked through one log. I will now do the setup for PID-toolbox. If I do anything wrong, Brian will correct me. At least I hope. And then I will look into Chiao's log. Did I pronounce this right? Let me know. Okay. No, this is fine. On pitch, you also get one motor into saturation. No, that's amp in, no, that's just amp in saturation. So your current scale is. Oh wait, let's find a full throttle run. Over here we have full throttle. What current? Your current meter is off, because it shows here is you're running full throttle, and this is the maximum that your current sensor can display, and it corresponds with the throttle correctly, and you're only pulling 36 amps, and you will pull more unless you have extremely shitty batteries. On this rig, I pull 65 amps on the small packs and a bit over 70 amps on the big packs. So it's double. That's double of what you are drawing. It's slightly bigger motors, but even on 44s, you should pull like 45. Should be able to pull 45 amps through the rigs. Otherwise, get better batteries. If you are looking for nice batteries for a 3.5 inch, check out those. That's GMBs. They fit nicely. It's HV batteries, so it's 4.35 volts per cell. But they hold up fine. I'll put 100 to 150 cycles on those, and I'm on my fourth batch. So they are GMBs doing them really consistent, unless they did a giant batch but adopted. GMB usually only makes runs of 1,000 to 5,000 from the not so popular sizes. It's like only the 6S 1,200 to 1,400. Those are made in bigger batches where you get more variation inside a batch, but more consistency over time. And those are made in small batches, and I bought them at 5 different times, so I know they hold up. They hold up really nice, and it's worth flying a pack, because this pack is, I think, 80 gram, and the GMB with the same capacity, slightly more punch, is 72 gram. That's almost 10 grams lighter than a comparable 650, and it helps to keep a rig if you fight to get under 250, and I know you are because you put a naked GoPro on it. Those packs are really the best I've found so far. Okay, let's head over and start to install PID-toolbox. And I say install because it's a procedure you need to have seen. And so we'll Google PID-toolbox, and yep, the first hit is Brian White's repository. Here again, always in on GitHub, here on the right side, you got the releases. You can jump directly to the latest release or show a list of releases if you need an older version, because I think if you run Linux, you need to go back to 0.56. You got hey, Kiss support is here. Hey Brian, I built a mirror rig for Phantom FPV. It's still there. It's my first Kiss build. I haven't flown it yet, but I need to get a logger for it. Did you look at the README? Yeah. Please, everyone, don't harass Brian with PID-toolbox is not working if you haven't read the README. So we'll download the zip file. Oh, now it's working again. Open it up. Put it in a very important folder. No, no, no. Okay. I just extracted to the root of my big drive. I'm not buying WinRAR. You open it up. Read the README. Honestly, I'll smoke the cigarette until you have read this README file. Can I make it bigger? Read the README file. I won't. I already have a couple of versions ago. But if something's not working as expected, I will read the new README file. Maybe there's new information on it. You never know. So you unzip the file. And in the main, you got the program, you got the helper files, because the blackbox logs are a binary format, which is really, really funny. We're just reverse engineering it, and it's really hard to decode it. But Betaflight devs just give you a decoder that makes a CVS file, and Brian is taking use of this. So you open the installer, My App Installer Web, which is just a redistribution of the MATLAB runtime, I guess. Say yes. Now you have a bit of time to read the README file. May take a couple of minutes. Yeah, sorry, I don't have a Mac over here. I used to work on Macs when they had the best hardware. Now they just have the most expensive hardware, and I can't be bothered to use the products. It's whoever likes it, and I won't do software. So now it's finished installing, and I don't know which directory it installs it, but whatever directory it did install something, ignore it. The main directory where you extracted your files has the proper runtime. Here is PID-toolbox.exe. Run it from the directory where you decompressed it into. Unzipped it. Could not find. Is the installer not ready yet? Oh, the MATLAB runtime was not. Ah, and it tells you to. Okay, is that a graphic tool toolbox? Okay, yeah, okay. I was too fast. MATLAB runtime. Yes, I want the new MATLAB. And again, while it installs, you got enough time to read the README. Yep, I will agree to the MATLAB's license. Yeah, Brian, I will. I'm away next week. Just running a little speed test. Oh. Yep. Okay. Yeah, that's best. Best I can get. At least no more dropped frames. So, because I can't see the chat right now. OBS has difficulties to reconnect with the chat. And stream looks like it works, but I can't hear you. Oh, danke. I just got the message where the workspace from UAV Tech is. 3.5 version. Okay. I downloaded that. Yep. We'll open it in a second. Just. Come on. I need to open YouTube to get the chat. Oh, come on. I have no idea if I'm still online. Honestly, I'm not. I don't know what's going on. Yeah, that's me talking an hour ago. No. That's the old one. Come on. I don't want this. Oh, I'm here. Now I can see the chat again. My router just was cut off. I didn't. I had to restart my modem and my router. I hope you can still hear me in halfway decent quality. Oh my God, that's so. For those who are still with me, I can't see the chat unless I explicitly open it. I'll put it here on the side behind OBS and mute it because you don't want to hear me 3 times. No, Brian, it was not PID-toolbox. It was the MATLAB runtime. You can't be held accountable for using the best tool for the job. Okay, we have PID-toolbox finally opened, and we'll open Xiao's log. If you find it in downloads, if this did work before it grabbed out. Nope, it should be in downloads. Yep, here it is. So, PID-toolbox, here you can open files and you can open multiple logs. If you have the same rig and you tried a couple of things in different logs, you can open multiple logs and compare them. This is a really nice, important feature, which makes it handy and more capable of Blackbox Explorer to directly compare. Thanks, Maelstrom. It's acting up like crazy today. I don't know what it is. Normally I don't have problems, but I have my nephew's rig over there. It's like 2 years fresher. It's like from beginning of this year, top hardware, so I'll use that. How big was that log, Joe? Yeah, but even browsing through Explorer takes forever. How big is this log? It's just a 16 max log, so usually opening a log like this takes a couple of seconds, 5 seconds, I would say, in PID-toolbox. No, don't give me a Mac. It's finally doing something. But I'll threaten the computer with the task manager. If you hover over, oh, yeah, OBS is hugging the GPU, but that should be fine. It's just 18% load and 30% total load with PID-toolbox currently parsing a log, so. Blame it on my computer having a bad day. Whoop. Oh, okay. That's how far back you are. If you are used to a way older version of PID-toolbox, it was pre 0.6, I think. You always had to put the logs into the same folder as the main executable. That's not like that anymore. You can set your directories over here. I think it will automatically default to the last open directory, so you can open logs from every place. Don't put your logs into PID-toolbox, into the PID-toolbox folder anymore. Brian fixed that. We are grateful. Okay, so Yeah, traces are a bit harder to navigate. I usually just take the full log. Sometimes if there is more than one crash in it, I will crop it to the crash. What I think it's the for me to me personally the most useful feature is the step response tool, which will give you a theoretical step response. Step response is the reply to an input that goes from 0 to 1 in 0 time. So it's a vertical line that will never happen in real time. You can't move your sticks that fast to open up an error in 0 milliseconds. So you will always just have inputs like this, but the step response convolutes it into a curve that would represent the response to a step input. So we just leave it on default RP and Y all access and run it, give it like another minute. It's not Brian's fault, it will be fast on your computer, but I'm too lazy to cut those streams together into smaller bits and pieces. So we'll wait. Brian, I have one question for you. Can you can the user scale the time access on the step response? Because I think it's half a second displayed, and you barely use more than, oh, it's half a second. You barely use more than 100 milliseconds. So it would be nice if one could scale this access either as a user or as a program setting. Let me know. So, Joe, what's up with your rig? It doesn't reach set point. So P is probably too low. You run a lot of eye gain on it. Quite a bit of feed forward. How does the rig feel? Yeah, it's a freestyle flight. Brian, why not? Yeah, it's the crash bingo. Can you get the flash forward before you crash? Use a higher locking rate. If you can only lock a minute, you probably won't crash within this time. So you are undershooting a lot, even with that much of, yeah, feed forward doesn't matter for the step response that much. It won't be the best for judging PD balance, but you're not overshooting a lot. And if jaw undershoots, it doesn't matter. You can turn the jaw gains up, but it's on emo flight you get a pretty nice jaw response with a little bit of D-term. I tried it on beta, but D is just too aggressive on beta because on emo flight they call it no feathered pits. I think feathered pits is the wording Quick Flash choose for it, where the D term is not trying to keep it the same, keep the angular velocity the same. It's trying to keep the slope the same as your set point. So if a set point with this direction, if a set point goes up, if you start a flap, D-term usually would work against it. But with feathered pits, you can choose a percentage which, if D-term wants to keep the velocity constant or keep the velocity the same as the set point, the same slope as the set point. And then you set a percentage where you say D-term, if set point does nothing, is 0. And if set point goes vertical, if you choose 50%, you will get this slope. If you choose 80%, you will get this slope. So D-term makes the quad a bit more responsive to the sticks. Betaflight decided against it and just use feed forward to compensate for fast stick moves. Ah, thanks, Nerdcopter. Yeah, but in between it just mixes the slopes. Or does it both calculations for the set point slope and uh, constant D term, and then interpolates with the value, or does it set the slope between it? Okay. I look at this in Blackbox Explorer at the moment. Just to give you a general idea, you can have multiple locks in here. Even if you disarm an arm, Betaflight will start a same lock. But if you download all locks, the Betaflight old file, it will compress all the locks into one file. It will write the header file in between, so it's the same as if you've got multiple files, but you just have one file with all the logs from this battery or from this rig until the flash went full. So you can use different values of D term to see how nice it approaches your set point. So your response time is reasonable. So here you got how much overshoot you get. So up to 1.1 on a hot tune, up to 1.2 is acceptable values. You should reach that point. Except from jaw. Jaw is fine if it can't make it. I have to check how Jaw's rates are. If he wants crazy rates on jaw, it's just physically not possible to spin with two props fast enough without gaining altitude. And the last column over here is the latency. How fast the gyro reaches set point the first time. If it overshoots, it will be a steeper slope and reach earlier, but it doesn't help if it overshoots too much. A little overshoot is fine, depending on how hot your rig is, how hot your tune is. What we got here is like 8.25 millisecond on roll. And oh, what frame is this, Joe? Because you usually, if you got a classical toilet tank, the battery is the biggest weight on single weight point on your quad. And if your prop line is over here, you see the prop line, this is on a normal rig, then the battery will be easier to spin on roll than on pitch, because you have the camera on the front, VTX at the bottom, and the big weight. When you go toilet tank, you make the battery less of a burden on the pitch axis and more on the roll axis. But the battery, the weight that is here and here compensates for the weight that is here and here. So on a toilet tank, you always have a better balance between pitch and roll. And a normal rig, pitch is always slower. But this on Chow's rig, pitch is even faster than roll, which is well, and it's nice values. You with a really sharp racing rig, you can almost reach 6 milliseconds. It won't go lower than this. It takes a millisecond for D-shot to get to the ESCs, and the ESCs, if you're sitting at 10% throttle on to the ESCs and you give them 100% throttle, they won't open up the fats fully to accelerate as hard as they can, because you risk these things. So on ramping up, on changing the velocity, you only give the ramp up percentage that you set in the ESC settings. You can play with it, you will get faster response, but you will risk these things. So this is a really nice rig, except you don't reach set point. So let's look at the spectrals. Takes couple of seconds. Yeah, Brian, you're right. Uh, Brian, the concept for the step response is P and D only. Usually, if you just want to balance P and D with the step response tool, don't use feed forward and don't use too much I-term. A little bit of I-term doesn't hurt. So you get poor P and D behavior. You want to balance P against D, and you don't want to balance D against P plus feed forward, or and you don't want to balance D against I term. So let's see. Gyro and gyro pre-filtered first. Brian, you probably don't want to hear this. I use step response always just a freestyle flights. If I have a quad that I don't know the geometry and the expected motor response, then I really do a wiggle and a couple of flips and snap rolls. But usually I just use a normal freestyle, a hard freestyle flight for it. So frequency plots. Frequency plot just gives you the frequency, the amplitude at each frequency in total over the whole log. We selected gyro and gyro pre-filtered. Gyro pre-filtered is always the higher line with more noise in the higher frequency range, and gyro is gyro filtered. So here all the RPM, noise, and frame resonance are usually taken care of, and there's a low pass filter. Got a good estimate about the delays. So he's running pretty low filtering on D-term at just half a millisecond of extra delay when I got it right. And here you got roll, pitch, and jaw. Jaw just gets the RPM filters and a single low pass at 100 usually. That's why they drift apart at 100 hertz. Here you see the RPM filter start a little bit earlier. Then you have a second plot for the region under 100, because this is what we are mostly looking at, and we expect D-term to be killed by low pass filters far above this range. So this looks nice. Just give D-term to see what the low pass is at for D-term though. Is it already done? No, it's not. Yeah. No, child, that's not a mess. That's normal. I think you can do the wiggle test on both axes at the same time now. But it will correlate the axis a bit. There is a little peak around 60-ish, but no, that's fine. You see this. the filter reaches down like almost, you have the cutoff at 80 over here, and it still takes a bit off down to 40 hertz, but that's fine. Brian, anything else I could show? What frequency over throttle? That's not my favorite. No, I don't want. Wait, it's preset. This is like the same as in Blackbox Explorer, but more at the same time, side by side, to compare them. I don't like the heat maps as much as the Betaflight heat maps. I think I'm just, for my taste, I'm missing resolution. Frequency over time. I'll have a look at this and see if because you're just gonna see when the noise is happening. Because I haven't used it in quite some time. Let's wait for it to finish the spectrograms. Brian, what information are you looking at when you check the frequency over time heat maps? Oh, you check the motor bands in frequency over time, because I check the motor bands in frequency over throttle. Those are basically the same plots that we just seen in Betaflight, Blackbox Explorer, but the axes are inverted. So you got the frequency on the y-axis, same, that's 2K log, so it goes to 1000 hertz, and you got the throttle on the x-axis. So we see the first motor harmonic over here. We see the chow barely touched over 80% throttle. It did a little over here, maybe 1 or 2 pumps. And we see the third motor harmonic. And now, of course, the frame resonances are horizontal lines. So we got somewhere at 410 and 200 hertz. We got our resonances, which is totally fine. Notches, as we see in the filter gyro, the notches don't manage to kill the 200 nor the 400 totally, because the scale is comparable. We can scale it a bit higher. If we want to see it a bit more pronounced. The D term always it's too much noise. I don't know why the scaling from the D term is so much. That's pre-filtered. Okay. Filter D term. Okay. Whoa. Okay. I thought I did it in the wrong direction. Let's reverse this. So the dynamic notches, if they're open, won't get rid of your frame resonances. I don't know. And now we'll check the frequency over time. Let's see what Brian's. Multi-bands, wiki. Okay. Pooh. Okay. Ciao. Are you? When did you install the 4.5? Do you know which date the build is from? So we could look into GitHub, run the Java pre-filtered. Yeah. Yeah, they're making fun of me for my network and hardware not working properly. Thanks for the kind words about my shitty stream. Okay. Okay, I see that the lines, the separation is much clearer because you're just looking at a single point in time. And the resonances are nice because you just see over the throttle, it will lighten up a horizontal line over it. Let's zoom in on this. Does it recalculate on zoom? Yeah, I see the resonances. Really nice here. Brian, I used such a plot from an audio file. That's really funny. You can. Which tool did I use back then? I used an audio spectrum analyzing tool for a Kiss rig just to get the resonances and the overall motor noise from an audio file. Because you have enough sampling rate in a good GoPro audio. Yeah, I get it. So you got, for example, take this. This is throttle, a little pump, and then it's a throttle ramp. And here up here you have the third resonance, the third harmonic of the motor noise. If you see double lines like those over here, it doesn't. If I run it again now, does it recalculate with the zoom value I've set? Let's try. Because those spectrums are pretty coarse. If you zoom in time, I guess I should set an in and out point at the traces. Yeah. Brian, I will play a bit around with it, use it a bit more, compare it to what I know from Blackbox Explorer, and cover this on my next stream if I manage to find something more useful, even more useful. But I will keep that in mind as a tool because I use it. So now I'll just open Charles Log in Blackbox Explorer. I'm too tired already. Okay. Mm. Yes, I know. Thanks, Brian. I'll try this. I try throttle ramps as well. So this could be useful to judge noise and judge frequency in specific situations. So you don't look at a 2-minute log and see what happens there. So you look at the 1 second that's interesting you, or 2 seconds that's interesting you at the moment. Here, PID-toolbox README file. Look at it. It hurts. It hurts if you wait for a computer. I used to do 3D animations. I used to wait half nights just for previews to finish or single frames. Here we go. Oh, that's quite a long log. It's 4 minutes. A lot of movement on the throttle. Damn, Chow, what are you doing in this log? A lot, a lot. Okay, let's look at. Oh. Let's see what system he's running. 250 hertz control. You are over dampened. Let's see if I can find something on pitch. That's pitch is a little better. Okay, let's see what you said. Yeah, I waited a minute for this to open. And now when I open it, I start rolling my cigarettes. I should have done it while I'm waiting. So you got a single gyro low pass at 700 PT1. You use the stacked PT1s at 1.4, which is... I usually end up on on a clean rig, if I do a safe tune, I usually end up at 1.4. Sometimes 135, sometimes I can go up to 145. I won't go. I have clean rigs with clean props. I can go to 1.5 with the D slider, with the D filter slider. But as soon as the props degrade, I got too much noise, and I want to be able to limp home with a blade broken off. And it with 1.4, this usually works. So, you got where your dynamic notches, 2 from 80 to 600, which is wider than you probably need. And you run little D. Why is it so? You D. You run a lot of D on pitch, and pitch is still that fast. Joe, you need to show me. Please post a picture of this rig. It's. I'm curious. I'm honestly curious. No notches, and the RPMs starting at 100. But this looks min RPM 20. What is this rig? Let's look at the noise. Did you went to steeper props or wider props or shallower props? From what prop to what prop did you change? Because I most of the times, if the prop is not much heavier, if the weight is about the same and just the pitch changes and the surface area changes, I just change the multiplier to tune for a different prop. Like I got a 2 point I fly mostly 3.5 inch, so I got this 2.5 inch pitch, and if I stepped onto a 2 inch pitch, I raise the multiplier by 20% and call it a day, unless it starts misbehaving. So let's see, gyro noise. Spank props. Yeah, they are heavier, and this is much more surface area. I think you're talking about the thin chamfer spank props that are supposed to spin up really fast. And then R35 is a race prop with a bit more surface area, and it's like 30% heavier. And that's a lot to spin up. So, noise. Oh, first harmonic, you got just a single on 190, single resonance. Let's see, pitch. Nothing on pitch. The second harmonic is a bit stronger. Does filtering work? Yep. Pitch. You could go a bit lower with the gyro low pass. I don't see anything that would give it a workout. But you don't have to. Because it's just a single low pass filter in a frequency range so far above your control range. So this is your control range. This is where how fast your quad can actually be moved. Everything above this could be filtered. You could set a really hard filter right at this line, but it will delay everything below the line like 90 degrees phase. So that's why we use the higher and go even higher. So at 80% throttle, your dynamic low pass on gyro will not cover this resonance anymore. There's a bit of noise at 144, but Yeah, that should be it. And the last one is at 435 and on pitch. Sorry for the slow computer. More time for killing myself slowly. Yeah, I'm not a big fan of spank props. That's oh, mm, let's see if you got a single throttle. No, we don't have a throttle ramp here. Let's look at throttle if you did a ramp anywhere. Yeah, he use a lot. So set the in point with I and the out point. Come on. With O. So now I still can see the full log, but spectrum calculations will be only done from this part here. Nah, that's still not more. It's funny that this is yeah. Problem is with Betaflight, Blackbox Explorer. It doesn't use a sliding window for feeding the FFT with data for these plots. It just allocates a block of 24K, no 240K, fills it with data and blanks the rest with zeros. So it's not very effective way of getting the best resolution, best frequency resolution out of your data. Because if you fill basically what Betaflight does, it calculates the FFT that goes up to 12 gigahertz, and then it cuts off everything until the Nyquist frequency. But you don't get anything. Let's take this lamp out 520. So notches should just make sure anything on roll. Is it roll now? No, it's not roll. Give me roll. Rolling, 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 rolling. Computer takes forever. Here it is. Is there anything? No. So 150. No, 150 to 600 should be enough. But I had a couple of cases where the dynamic notch didn't catch a harmonic that was right above the cutoff frequency for the notch filter. So from 80 to no, you're fine. You can go higher with the minimum. You can go up to 140. Put in a third notch. Sometimes it misjudges what is the highest peak and take the second highest and third highest peak instead of the highest. And the notch always takes some time to adjust to the frequency. So when you got 3 frequencies left over after RPM filtering, and you got just 2 notches, those 2 will jump around, or one of them will jump around, and every time it jumps, it doesn't catch the frequency until 8 samples later. Rest is fine. Ciao, why are you not running Dynamic D? I see a lot of people. Sometimes it hurts with tuning. It makes tuning a little bit harder, but it helps a lot to keep a smooth rig at low speed, at cruising, and still be sharp at stopping snap moves. So let's. Okay. How do I kill the endpoint? And I might be online again. OBS says I'm online again. Whoever's still here. Pictures. Ciao, those are the big FPV cycle motors. The what I call 25s. Problem is I don't know if you hear me. No, YouTube didn't. I just need to reload YouTube. Damn internet connection. Loading. Here we are. Maybe. Maybe not. Okay. I hope you hear me. So it's a really big stator. They shouldn't have a problem spinning up the R35s as fast as they spin up, almost as fast as they spin up the spank props. So you need to go a little bit lower with your overall gains, and then you can push P a little. So where does the noise happen? What's your max rates? No, we're not hitting it. Here we're hitting it. Yeah, that's smooth rates. And yeah. Two things for filtering, Joe. Go use a static notch if you have problems covering this. Let's see what happens here. That's 400 hertz. That shouldn't even be visible. Yep. That's. Oh, that's the third harmonica. No, leave. There is a pull request from Jan, I think, Karate Brot, for on the master branch of Betaflight, where you can individually scale the RPM harmonics. So you can, if you flash the pull request, you have a CLI option where you can set you can set the second harmonic to 0% and the third harmonic to 50%. So it will be as fast as almost as fast as just a single harmonic, but it will cover your third harmonic if you want to give this a try to get faster response rate. But this is something to try to turn around. It won't make too much of a difference. It will help, but it's not. Oh, you're using this. Okay. Yeah, so this is working. Nerd knows the PR number. Nerd, you are. Okay. Use a small static notch on the single harmonic you got, and stay with two dynamic notches from 120 to 500. So anything that's still happening at low throttle is this. And Ciao, are you flying a lot inverted? Because you said 20 RPM as min frequency, at min RPM, and that's 20 is 2000 RPMs, and that's really low for a 5-inch prop. That's values you would see on an 8-inch, more on an X class upwards. And you don't gain considerable hang time going from 30 down to 20, and it will give you a lot of problems when you cut throttle, when you push up again. So give that a try. It's already over 2 hours. My wife is waiting at home, or maybe sleeping. And look,